Time for a CAD CAM CNC project? Well, I'm just going to show you how you build up a CNC project. This is Fusion 360. You start with a sketch, and what I'm trying to build here is a stand for one of my test devices. I use a tab in pocket or a tab in hole type design so that I don't have to glue it together. I'm getting everything set up here. It takes about a good hour to get all these holes figured out, how big they should be, how thick the plywood is. It takes a long time to just get everything squared up and so the holes all line up. I'm just going to tell you that it took longer than it looks, and let's say we spent a good hour in this portion just to get the sketch going. Then the next part is extruding it. So I'll step forward in the design. We take the extrude it to the thickness of the plywood, which is just slightly less than 12 millimeters. And then I duplicate it, or I look it over. I also rounded the corners. So that was the previous step. Then I duplicate it. I'm going to fill that hole because the bottom doesn't need that hole. I could do it another way by just not doing that tool path, but I decided to make it a separate part. Then I make the side. I use a subtraction method to get the alignment just perfect on the holes. So here I subtract the part, and then it's got the tabs already built into it. And I'll make two of those. I only have to make one part in the CAD. I can make two in. Now I have to lay the parts down like a sheet of plywood so I can fit them on the sheet of plywood. So I've built it in 3D. Now I'm laying it out flat. And I think the last thing I do is fill the hole. There I did. Okay, I'm ready to go to the machining phase. So that's a good hour. If you know what you're doing and you know what you want to build, it's a good hour to get to this part. Now I'm in the machining part, and I'm going to go through the tool paths required. I've got my origin there on that one, and I'm going to spin it around here. It's never easy to orient it the way you want. Okay. There we go. So I've got it, my origin. And you just want to make sure that it's not going to pass over a screw that's holding down your plywood. And then you make these little drill posts. And the reason you do that is because of the radius of the bit. You can't make an inside corner less than 3 millimeters with a 6 millimeter diameter bit. So you have to make these drill holes that'll cut out the corner. Otherwise, the post won't fit inside. Then you have to carve out that material on the inside. On this one, it's a pocket. I used a pocket. That's a helical path to get in there, and then it just cleans out that whole pocket. And then I cut the part out. This is the exterior contour. Sometimes you use tabs on this. I didn't use tabs on this. These parts were pretty heavy, so they weren't going to fly around when the bit got done. But about 3 loops around that, and that part is done. Going to the next part, this one's got an additional tool path. So we have the same, I had to generate it anew because I redid the size of this hole. So again, we drill the corners. All the inside corners get drilled. So if it's an inside corner, it has to be drilled. It's pretty easy to find those locations. And there's something like 18 of these holes that have to be drilled. And that happens pretty fast. Then I do the bore. This is a 6-inch bore, and you have to adjust the helical. I think I did 1/2 a degree, and that worked out pretty good. The default is 2, and if you try to do a 6-inch hole with a 2-degree helical, you're going to bury that bit in wood, and you start smoking. All right. So on this one, I had to do contours on the inside. For some reason, and I spent 20 minutes trying to figure out why the toolpath wouldn't go, I ended up doing a contour. And that's some of the things that really no one seems to plan for, is that sometimes the tool paths just don't work. So this is the third part. I'm going to do 2 of these. And again, inside corners get drilled, and then there's a contour, and it'll go around all the parts. So I'll do a simulation here, and you can see how how the bit. It's always recommended you do a simulation before you actually cut it on plywood, because you never know what you're going to run into. So here's the simulation. It's going pretty fast, but it's drilling all the holes. I'll slow it down here, zoom in a little bit. So you can see it's drilling the holes in the inside corners. And then it's going to go back and it's going to clean those pockets out, or these are contours. So it's going to just contour that out, just cut out. So contour's different than a pocket, but it works. It just wouldn't execute a pocket, and I don't know why the holes are any different than the other one. All right, we have the part bolted down, and we are getting started here. I'm starting to drill the holes, and then I'm having a thought that maybe I didn't include one of the tool paths to clean out the pockets for the tabs to go in. I'm drilling the holes, but I didn't. And the key thing is here, if you include a contour path to cut the part out, you got to get everything done before you cut the part out. So I stopped it and went up and included those. That took another 20 minutes to put those tool paths in, check them out, make sure they're going to work. For some reason, the holes are not the same for the first 2 parts, and it wouldn't do a pocket for the second part. I did a contour. So now we're finishing up the holes. We're on the home run or home stretch for the holes, for the drill holes, and then we're going to do pockets to clean out everything between the holes. So here we go. We're helicaling down to the bottom of the wood and then just moving across the wood, cleaning out the pocket. It's 6 1/2 dozen of another for pockets or contours. These are going all the way down. They're complete bottom of the wood. So contour works just fine. Sometimes I'll separate all the tool paths so I can cut the part out on a separate tool path to make sure I get everything done. But this is a fairly simple part. All right, we're finishing up the, we're going to do the, cut out the part contour. And this part doesn't take very long, maybe a minute to go around it 3 times to cut it out. Sometimes it's got tabs and you have to cut the part out. And sometimes you don't cut all the way through and you leave this a nice thin piece of material that won't let the part come free. If it's much smaller than this, you got to put tabs in. All right, this is the last perimeter. And we're done. That part is done. It does pull out later. All right, I'm moving the origin up for the next part, loading the G-code up for the next part. This is the one with the bore in it. It's got a hole in the center. It's 150 millimeters in diameter. I'm adjusting the camera a little bit, and we're drilling the holes. Drilling holes is a normal part of this type of construction. My goal was something I could put together without glue or screws. And this did work. All right, we're just about done with the, and then we're going to do our contours. There we go. 3 passes, 3 passes. It's going down 4.5 millimeters each time. and that is enough for that bit at this. You don't want to put too much force on the plywood or the bit. There's only 4 screws holding this plywood in, and you really don't want to push it too hard. All right, we got one more hole after this. Here we go. Now we're going, I got one more. Okay. Then we are going to go for the bore. Now, the bore is a 1/2 degree. I don't know if it's per loop or what, but it's got to go down 12 millimeters, and the default is 2. And I tend to bury the bit in the wood and it smokes if I use that default setting. So I set it to 1/2. And it works pretty good. I've removed the piece in the back, and that disc is free. All right, so now we're going to cut the part out. That's pretty good. Now, I don't think I recorded the next 2 parts. However, it was a 1/2 hour to cut out all the parts, and another 15 minutes to sand them and clean up. So that's if you're working efficiently. All right. These are realistic time goals. The idea, I didn't know what I wanted. I was thinking of making out of metal. I figured 20 minutes. CAD was 60 minutes if you know what you're doing. CAM is 60 minutes again if you know what you're doing, and sometimes it's longer. Stock prep, 30 minutes. You got to get it out of storage and fix it to the table so it's square. Then when you get the parts cut out, you got to sand them. Then you got to sweep up all the sawdust, because man, it makes a lot of sawdust. And then you pound them together in about 10 minutes. So total for this part was 4 hours.